Hello, my name is Santiago Martinez, and today we're going to be going over Exam 1, Problem 1. Due to lack of app usage and the app that I purchased was not cooperating with me, I lost my audio. So we are going to go over these problems once again, and I'll walk you through again step by step of my thinking process of each answer. So our first question is asking us 1a, what is the definition of a function and a one-to-one function? The original question asks for a one-to-one function, but while we're here, we might as well talk about the definition of a regular function as well. So a definition of a function is that every x value, let me adjust my highlighter, excuse me. Every x value or an input value, they're the same, interchangeable. Every input or every x value has an output. Very simple, right? We plug in an x value, it's going to have an output. It's also important to be a function. A function can have multiple x values that have the same y value. So we could have a situation where different x values, right? So let's say if we're talking about -3 and then 3, they both can have the same y value or output. But it's important to note that we cannot have the same x value. There can't be two negative ones or two x's, regardless if we're looking at a function of a one-to-one or a regular function. So now let's specifically talk about a one-to-one function. So a one-to-one function is where every x value has a one y value and every y value has exactly one x value. Again, we can use the terms output and input. That helps me really visualize it as well. So if we were to re-say it, a one-to-one function is where every input has exactly one output and every output has exactly one input. So in this situation, there cannot be multiple x values that has the same y values. Has to be original every single time. So let's explore this a little bit more. So B is asking, of the given chords or the table and graph, which is down here, determine which ones that are functions. So we're looking just for regular functions here. And we can note if we see a one-to-one or not a one-to-one as well. So looking at this, right, always check your x values first, right? We have 7, -4, -2, 2, 5, and 8. We're good. There's no repeats. There's no multiple x values that will make this not a function. But if we look over here, we should have -1 and -1. This meaning we have a duplicate of a y value, so this would not be one-to-one. So when we put that in statement form, we say each x value has a y value and there are no repeats in x values. So this would make it a function. This isn't a one-to-one due to there being two of the same y values, as I explained over here. Now let's move to the second image, which would be a graph. And if we're given a graph like this, right off the bat, we see it's a circle. We know it's not going to be a function, but we have to explain why it's not going to be a function, or definitely not a one-to-one. Another way to tell if something is a function is the vertical line test. This will show us if there's any multiple x values, right? So if we take a look at this, if we draw a straight line on one x value, there's going to be this same x value here is going to hit multiple times throughout this line and throughout our graph. So we know for a fact that this cannot be a function. We have two hits right here and right here on this x value. This cannot be a regular function. And let's say if we had another graph and we wanted to do see if it's a one-to-one, we can use something called the HLT, which is horizontal line test. So obviously this isn't a function, so we wouldn't have to do this, but just for example, let's say if we run a horizontal line here, we get 2 points. So that means an x does share a y value twice. Different x's share the same y value twice. So that would make it's not a horizontal line test. And yeah, that's walking through this first part of the exam. And thank you so much.